All right, everyone, let's take a look at slide number 10. It says drag point A to move the parabola so that its roots are the two open blue points. So I'm going to go ahead and drag this, and let me lift this up a little bit. I'm going to drag it until the roots are touching those two open blue circles. So as best as you can. And there we go. So looking at this, it appears the roots are 2, 0 and 6, 0. I have two x-intercepts, one at x equals 2 and one at x equals 6. All right, so let's examine what this is saying. It says, what relationship do you see? The parabola describes this equation. What relationship do you see between the function and its roots? So if we're looking at the function, and we've seen a quadratic function before, so what can you say about the relationship? We can see the roots. What are the roots? They are the x-intercepts. Use what you noticed on the last screen to write the function for a parabola whose roots are two open blue points. So I can see I have two open blue points, one at 4, 0 and one at 7, 0. So I'm going to go ahead and write the factored form. That means I have a, if you remember, using the zero product property, if I have a root at x equals 4, if we subtracted 4 on both sides, we would get x minus 4. And if we did the same thing for the 7, if I have that x equals 7 and we subtracted 7 on both sides, we would get x minus 7. So we can write our two factors as x minus 4 times x minus 7. Now, if you do it correctly and press submit right here, then the graph should overlap those x-intercepts. Write a function for a parabola whose roots are the two open blue points. So this is the same idea. Looking at this one, if x equals -3, then how would I write that as a factor? You can add 3 on both sides. And so we would get that x plus 3 equals 0. And when we are looking at an x-intercept right here, that means our y is equal to 0. So we can write our factors here as x plus 3 times x minus 2. Since we can use the same argument as we did in the previous slide, if x equals 2, subtract 2 on both sides, we would get x minus 2. So you can check your work by pressing submit, and you could see that the parabola goes through those blue points. All right, so let's use our knowledge to see what happens if we have more than one x-intercept. So we have an intercept at -2, at 2, and at +6. So if you want to pause the video and see if you can get this on your own, and I will go ahead and go over this. So if I have an intercept at -2, that means I have a factor at x plus 2. If I have an intercept at x equals 2, that means I have a factor at x minus 2. And if I have an x-intercept at x equals 6, that means we have a factor at x minus 6. So let's go ahead and submit those three intercepts and see what happens to our graph. So we can see that the graph is going through all those x-intercepts. All right, looking at slide number 15. If possible, drag point A to move the cubic so that it has only two roots. So what we want to do is right now we have 3 roots. I want to drag this A where I'm only touching the x-axis at 2 points. So if I drag it down, I can do that. In other words, right here it's touching at 1 point and then at one other point. Or we can also go the opposite direction, and I could bring my I could drag my graph so it touches it at 1 point here on the right and then one on the left. So there could be many different answers here for what you write down for this. All right, so let's go ahead. I'm going to leave it at this location. So I have a decimal here. 0.325 is an x-intercept. And I also have an x-intercept at negative 3.14. Looking at what I dragged my A point to, let's go ahead and write the intercepts the way we have done with the previous graphs and see what happens. So I have an intercept at negative 3.14, so I'm going to write x plus 3.14. And then I have another intercept at 0.325. So I'm going to go ahead and write x minus 0.325. Now let's submit and see what this graph looks like. So when we submit, we see we actually do go through those 2 intercepts, but the graph doesn't match. So what is the reason the graph doesn't match? Because what I have here is a parabola. But if you look at the orange graph, it is not a parabola. It looks like I have a graph that is a cubic function. So we've looked at cubic functions before. And if we look at our factored form, we have degree 1 times degree 1, which makes it a degree 2 polynomial. So right here where I have this graph touching 0.325 and then going back up, we call that a bounce. So it's like a ball came down, bounced on the x-axis and came back up. So I need to square these points, this point right here, because this is what we call a double root. So at 0.325, I'm going to go ahead and raise it to the square. So this point right here is called a double root. So I'm going to go ahead and fix that, and you could see that now the graph goes through it properly. All right, let's go ahead and using this idea, I have x minus 3 squared, x plus 2, and x minus 1 all multiplying together. So how many roots do we have? How many do you think? This one here, even though it's degree 2, I can rewrite this as x minus 3 times another x minus 3. So we actually have a root at x equals 3, but we have the same root occurring at the same place twice. So we call that actually a double root. And we're going to count it as a, I'm going to write x minus 1 here. So if you look at these factors, I actually have 4 factors, but this one here occurs twice. So we're not going to count it in our root as an extra one. We're going to call this as 1 double root and 2 other single roots. So this is a total of 3. So we're going to say over here that we have 3 roots. So correct, since there are 3 different factors, there will be 3 roots. Explain what happens on the graph when one of the factors has an exponent 2. The factor with exponent 2 is a double root. Okay, and let's go ahead and look at the last graph. The last graph is something we may have not seen before, but using the idea of what we did with a point that bounces off the x-axis. Think of what happened last time the point bounced off the x-axis. We had a degree 2. It was a quadratic. And then we have a single root here and another single root here. So if you want to pause the video and try to write the equation, go ahead and do so. So I'm going to go ahead and write the first one here was x minus 1. So I'm going to write x plus 1. But there is a bounce there, so I'm going to go ahead and put it degree 2 because this means there are 2 of them. And then I have an x-intercept at 2, 0, so I'm going to go ahead and write x minus 2. You can already see some type of graph forming here. The red graph shows you right now I have a cubic function that bounces off -1 and then goes through 2. But there is one more intercept, and that intercept is at 4. So I'm going to go ahead and multiply that by x minus 4. And you can see that the graph overlaps this equation, so that matches. All right, everyone, so let me know what you thought about this assignment. You can press the plus button here and add a little note. Let me know how well did you understand this. And I'll see you next class.